Hello everyone, my name is Shyam Chauhan and today we are going to cover exercise 1.2 question number 3. In question number 3 we have to prove the following numbers are irrational number. That is, first one is 1 by root 2, then we have 7 under root 5, and third we have 6 plus root 2. We know that the irrational number are of the form under root prime number. For example, we have root 2, root 3, root 5, root 7 and so on. The techniques to prove these numbers are irrational, we will do the fourth step, that is given the statement that is the number 1 by root 2 is irrational, we will assume the statement is false, that is the number 1 by root 2 is not irrational, it is rational. Then we will try to prove the assumption false, and hence the given statement, that is 1 by root 2, is true. The approach we will use is we will try to make the subject the under root number. Let's say, for example, in 1 by root 2 we will assume that this is a rational number, that is of the form a by b, and then we will make the subject root 2, that is equals to b by a. In second example, it is 7 under root 5, and in third 6 plus root 2, that is equals to a by b. We will make the subject under root portion, that is root 2 equals to a by b minus 6. We have assumed that a by b is rational number, that's why a by b minus 6 is rational number, and hence under root 2 is rational. But we know that under root 2 is not rational. We will prove that root 2 is not rational, and hence our assumption, that is 6 by 6 plus root 2 is rational, is false, and hence the given statement, that is 6 plus root 2 is irrational, is true. So let us start the proof. That is, first 1 by root 2 is irrational. Statement is 1 by root 2 is irrational. We will assume that one by root 2 is rational. If 1 by root 2 is rational, we can represent the number 1 by root 2 as the form a by b, where a and b are integers. Because we have to do the reciprocal, that is under root 2 equals to b by a, we will assume a not equals to 0 and b not equals to 0. And one more thing, we will assume that a and b are co-prime numbers. I have made the detailed video on co-prime numbers, that is the numbers which have the common factor only 1. For example, 8 and 9 are co-prime numbers. 8 have the factor that is 1 and 2. 9 have factor 1 and 3. The common factor is 1. That's why 8 and 9 are co-prime numbers. So that is root 2 equals to b by a. We have root 2 into a equals to b. Squaring both the sides, we will get 2a square equals to b square. If we see here, that is a and b are co-prime numbers and 2 divides b square, that is 2 is the factor of b square. And by theorem, we can say 2 is factor of b. So we can write b equals to 2 into some another constant, that say k, where k is an integer. If we take one small example to understand this, that is 12, we have 2 as one of the factor, so we can write 12 equals to 2 into some another constant, that is 2 into 6. This is similar to that. If 2 is the factor of b, we can write b equals to 2 into k. If 2 is factor of 12, we can write 12 as 2 into k. Now put b equals to 2k in this equation, that is 2a square equals to b square. 2a square equals to 2 into k whole square, because we have b equals to 2 into k. 2a square equals to 2 square is 4, k square. We have a square equals to 2k square. Now if we see here, 2 divides a square, that is 2 is one of the factor of a. This implies 2 is factor of a square. And by theorem, we can say 2 is factor of a. But this contradicts the fact that a and b are co-prime numbers, but 2 is factor of b and also 2 is factor of a. 2 is common factor of a and b, and this contradicts the fact that a and b are co-prime numbers. This arises because we have assumed that 1 by root 2 is rational number. Hence, the assumption is wrong, and the statement one by root 2 is irrational is true. Now part 2, that is 7 under root 5 is irrational number. The statement is 7 under root 5 is irrational. We will assume that 7 under root 5 is not irrational, or we can say 7 under root 5 is rational number. If 7 under root 5 is rational number, we can represent 7 under root 5 of the form a by b, where a and b are integers. We have b not equals to 0 and a and b are co-prime numbers. Now under root 5 equals to a upon 7b. A and b are integers. And we have 7b not equals to 0. So we can write a upon 7b is also integer. So under root 5 is n 7 a upon 7b is rational number. So under root 5 is also n rational number. If question is of 2 or 3 mark, then you can directly write that it is fact that under root 5 is irrational number, and hence our assumption is wrong, and the statement that is 7 under root 5 is irrational is true. If the question is of 5 mark, you have to prove that under root 5 is not rational number. So for 5 mark, we have under root 5 is rational number. So we can represent under root 5 equals to m upon n, where m and n are integers. Then we have n not equals to 0, and we will assume that m comma n are co-prime numbers. So this is equals to under root 5 n equals to m Squaring both the sides, we will get 5n square equals to m square. Now if we see here, m and n are co-prime numbers, but 5 divides m square. This means that 5 is the factor of m square. Five divides m square implies 5 is one of the factor of m square. And by theorem, we can say 5 is also the factor of m. So we can write m equals to 5 into some another constant, let's say k, where k is an integer. If we take one small example, that is 5 is the factor of 35, that is 5 divides 35. So you can write 35 as 5 into some another constant, that is 5 into 7. If 5 is the factor of m, we can represent m as 5 into some another constant. We have taken one small example, that is 5 is the factor of 35. So you can represent 35 as 5 into some another constant k. Now let us continue our proof. We will put m equals to 5 into k in this equation. That is 5n square equals to m square. We have m equals to 5 into k whole square, that is equals to 5n square equals to 25k square. Dividing both the sides by 5, we will get n square equals to 5k square. Now 5 divides n square. This means 5 is one of the factor of n square. And by theorem, we can say 5 is also the factor of n. If we see here, we have assumed that m and n are co-prime numbers, so there are no other factor in common other than 1, but we have 5 as factor of m, and 5 is also the factor of n. This contradicts the fact that m and n are co-prime numbers. This contradiction arises due to our assumption, and hence the assumption is wrong and the statement (7 under root 5) is irrational number is true. Now let us solve part 3, that is 6 plus under root 2 is irrational. The statement is 6 plus under root 2 is irrational. We will assume that six plus under root 2 is not irrational, or we can say 6 plus under root 2 is rational. If 6 plus under root 2 is rational, we can represent 6 plus root 2 as of the form a by b, where a and b are integers, b not equals to 0. If we make the subject under root 2, that is equals to a by b minus 6, we have a by b minus 6 is rational number. If a by b minus 6 is rational number, this implies root 2 is rational number. If root 2 is rational number, we can represent root 2 equals to m upon n, where m and n are integers. We have n not equals to 0, and we will assume that m and n are co-prime. This is equals to root 2n equals to m. Squaring both the sides, we will get 2n square equals to m square. If we see here, 2 divides m square, this means that 2 is one of the factor of m square. Two divides m square implies 2 is the factor of m square, and by theorem we can say 2 is also the factor of m. If 2 is the factor of m, we can represent m equals to 2 into some another constant, say k, where k is an integer. If we take one small example, that is 2 is the factor of 14, so we can represent 14 as 2 into some other constant k, where k equals to 7 is an integer. If 2 is the factor of m, we can represent m equals to 2 into some other constant k, where k is an integer. If we put m equals to 2 into k in last equation, that is 2n square equals to m square, we have 2n square equals to 2 into k whole square, because m equals to 2k. Two n square equals to 4k square. This implies n square equals to 2k square. if we see here 2 divides n square, this means that 2 is one of the factor of n square. And by theorem, we can say 2 is factor of n. But this contradicts the fact that m and n are co-prime. If m and n are co-prime, there is no other common factor than 1, but we have 2 is the factor of m and 2 is also the factor of n. This contradicts the fact that m and n are co-prime. This contradiction arises due to our assumption is wrong. And the statement that is 6 plus root 2 is irrational is true. This ends the chapter number 1. From next lecture we will start chapter number 2. Thank you.